Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, Mrs. Aram Shahid is here from Pakistan School Salala to teach you something about important facts of making compounds and chemical bonds. As you have seen that molecules are combination of two or more different atoms, and they are combined chemically, so they make a bond between them. So we have to see something details about chemical bonds. It's a force present between two atoms that hold two atoms together. And there are two types of bonds over there, the ionic bond and covalent bond that we will see here. Merely our lesson today is about ionic bond, and covalent bond we will see in our next video. So before have an explanation of chemical bond, we have some questions. We have to think those questions. Number one is, why do elements need to make bond? What is outermost shell? What is electronic configuration? What is stable electronic configuration? And what are ions? So all these questions will be our lesson today. One by one we will be discussing them, and we will be knowing in the end of lesson you will be able to answer all the questions. So please keep on watching video keenly.
A chemical bond is an attraction between two or more atoms that holds the constituent parts of each atom together, or, to use the language of chemistry, that enables each atom to gain stability. A chemical bond is not a physical structure, but an energy relationship. There are different types of chemical bonds, but all involve electrons which are either shared or transferred between the bonded atoms. For an atom to be stable, its outer shell of electrons, its valence shell, must be full. For most elements, the valence shell can hold 8 electrons. Due to their small size, atoms of hydrogen and helium can only hold 2 electrons. Among single atoms, the valence shell is full only in inert or noble gases like helium, krypton, neon, and others along the right side of the periodic table. Noble gases have a very stable electron configuration and, as a result, do not seek to bond with another element. But for all other atoms to be stable, they must gain or lose electrons or share them with other atoms. A chemical bond is an attraction.
Hopefully you find all the answers from the previous video. Watch that video again and again so that you will be able to know what is valence shell, what is stable configuration, and why do atoms they join together to form compounds. Next question our is, that is ions. Atom loses gains electrons to become an ion. If an atom loses electron to, it will be positive ion, and its name would be cation. And if the atom is going to gain electron, it will become a negative ion, and it is named as anion. Here is again a periodic table display before you, dear students. So you have to see that ionic bond is formed between metals and non-metals. So first we have to locate metals and non-metals division in the periodic table keenly. So this gray part, all you can see here are metal. So left side of periodic table is all metal. Some are alkali metals, alkaline earth metals, transition metals, and these are again transition metals, and they are also called as F block elements. And these are staircase elements. These are metalloids. Metalloids are borderline between metal and non-metal. Here, this brighter part you can see all they are non-metal. So 8 group elements you can see they all have their complete electronic configuration. They are stable. They will not be involve themselves in any kind of chemical bond, either ionic or equivalent. So they remain in the atomic state because their electronic configuration are complete. So if we talk about these all rest elements, metals and non-metals, they all have partially filled electronic configuration. So metals, as we are concerned, only group 1, group 2, and here some few metals from here staircase. They all will be we are going to see these metals. They are going to react with this non-metal part of periodic table to form ionic compound. So again we have to see that ionic bond, it is formed between metals and non-metals. A bond formed by complete transfers of electron is termed as ionic bond. So ionic bond metals, as you can see, they have a tendency to lose their electron. They have either 1, 2 or 3 electrons in their valence shell, outermost shell, so they can be losing those electrons and then acquire a noble gas configuration, that is complete 8 electrons in their valence shell. And again, non-metals, they have in their valence shell, they would be having 6, 7 electronic configuration, 6, 7, 5, 6, 7 electrons, and they have a tendency to gain electron. So non-metals have tendency to gain electrons and they form negative ions, anion, so as to attain the noble gas configuration, that is a stable configuration. So once the positive and negative ions they are formed, they have developed electrostatic attraction between them. So this an electrostatic force that tends to keep opposite charges together is called as ionic bond. So ionic bond is formed by complete transfer of electrons to have a ionic bond. Let's have an example of formation of sodium chloride to see the formation of ionic bond. So if you can see here that sodium have got atomic number 11. So it have got 2, 8 and 1 electron. So 1 electron present in the valence shell. It have ability to lose this electron to this chlorine atom. So when it is going to lose this electron, it will acquire a positive charge. Sodium positive charge, and it become cation, sodium positive, having stable configuration, 8 electrons in the valence shell. So what happens, this chlorine atom is going to gain that electron and become a negative charge anion, and the positive and negative ion, they have developed ionic bond among them. So chlorine electronic atomic number was 17 and have 7 electrons in its valence shell, and when it gain 1 electron from sodium, it will be having 8 electron in the valence shell. So its electronic configuration is complete as that of noble gas. So you can see that sodium positive and chlorine negative, because they have given 1 electron and became sodium positive ion. It have gained 1 electron from sodium and became a negative ion. So in this way, their attraction make up a compound called as sodium chloride. As you can watch, as you can practically how this compound is formed experimentally. Let's watch.
When a piece of sodium metal is added to a flask of chlorine gas, a vigorous reaction takes place that releases a lot of energy, and sodium chloride, a common table salt, forms. The chemical details of sodium chloride formation are similar to the formation of many other simple ionic compounds. Let's view the process of ionic compound formation on the atomic scale. Many chemical reactions occur through a series of steps. In the process of ionic compound formation, the key step is electron transfer from the metal to nonmetal to form oppositely charged ions. As a chlorine molecule approaches the sodium surface, yet before it makes contact, electron transfer occurs. Then a series of rapid steps, too complex to detail here, forms free chloride ions that are attracted to sodium ions and energy is released. Let's isolate the key step and examine a simplified version of it. Electron transfer from a metal atom to a non-metal atom. The sodium atom has 11 protons and 12 neutrons in its nucleus, and 11 electrons around the nucleus. The chlorine atom has 17 protons and 18 neutrons in its nucleus, and 17 electrons surround it. The sodium atom transfers an electron to the chlorine atom, and the ions attract each other and release energy. The loss of the electron converts the sodium atom into a smaller, positively charged sodium ion, Na+, while the gain of the electron converts the chlorine atom into a larger, negatively charged chloride ion, Cl-. Let's view this essential step once more. Electron transfer and ion attraction occurs countless other times between the sodium and chlorine. The large quantities of energy released vaporize tiny clusters of ions, and these attract others and release more energy. The clusters eventually aggregate and coat the walls of the flask. And even though table salt is not obtained this way, the product of this reaction consists of the same regular array of ions that makes up any sample of crystalline sodium chloride.
Let's see another example of formation of magnesium oxide ionic bond. Magnesium is metal and oxygen is non-metal. Magnesium will lose 2 electrons to form a positive ion, cation, Mg+2, and have electronic configuration stable in its valence shell, outermost shell. Oxygen have got 6 electrons. It will gain that 2 electrons from the magnesium and will have electronic configuration 8 in its valence shell, that is considered to be complete electronic configuration. In this way, magnesium +2 ion and oxygen -2 ion become a compound, ionic compound, magnesium oxide. As you can see in the picture, the valence shell electron are going towards oxygen atom. So oxygen, all they have 8 electrons, and magnesium also have 8 electrons. So in this way, positive ion and negative ion, they develop ionic force, ionic bond between them, and hence the magnesium oxide compound has been formed. Let's have another example, potassium fluoride. It's given in your exercise as well. So here again, potassium is metal and will lose 1 electron to acquire noble gas configuration, that is 8 complete valence shell, and it will give 1 electron to a fluorine atom. Fluorine atom have 1 electron less in its outermost shell, that is 7. So it needs 1 electron it will gain from potassium and will acquire the noble gas configuration, that is 8 electron in their valence shell. So now fluorine is happy, and when fluorine gains 1 electron from potassium, it will be having minus charge on it, so it is anion. So cation, anion, due to their attraction, potassium ion, fluoride ion, their attraction results in the formation of ionic bond, that is called as potassium fluoride. Here's a recap of a chemical bond. That chemical bond formed by complete transfer of electron is called as ionic bond. You have learned many examples, and please keep on watching video lessons. In our next video, we will be learning about covalent bond. Hopefully you enjoyed video lessons of formation of different elements joining together to forming a compound, and the compound formation you have learned their types like ionic bond, and you enjoyed examples. Please do practice for all the examples by drawing. Use compass when you draw You can also make models of your examples, and please, when you draw in your notebook these examples, they should be you should draw on the color paper and then paste it on the notebook, so that your notebook will become an interactive notebook. Thank you very much. Keep on watching our lessons videos, and keep on learning. Thank you very much. Allah Hafiz.